So other function they have for us is called cosine function. And turns out if you try to compare way graphs would correspond to each other, you're gonna see that they just like if we shift it by pi over 2 and produced from one graph the other. So if it's a cosine function, and they have a graph for us right here, then if I move this graph by pi over 2, then the graph will bring me to function sine of x. And of course, this is not just the whole thing, but periodic wave, so it repeats with period of 2 pi. And that's, I guess, the key idea to realize. If you know how to graph this wave with from 0 to 2 pi, then you can just add a few more pieces to the left and to the right and get the idea of entire graph. So let us try to graph some of these functions, sines and cosines. So I'm going to try number 19 to start. This deals with 5 over 3 multiplied by sine function. And the sine will be taken of negative 2 pi over 3 times x. Okay. So first of all, it's good to realize that we're dealing with the graph of function sine. Then I also noticed the graph needs to not go upwards when we start at the origin, but downwards, and then return back to the axis somehow like that. So the idea is, when does it end? Or where does 2 pi supposed to be? What does that mean? Well, I have to put my argument of function, which is 2 pi over 3 times x in between of 0 and 2 pi. So that's standard procedure, so 0 and 2 pi, because the period is 2 pi. And then I'm going to need to pull x out. And to do this, I'm going to have to use the reciprocal of this fraction, which is going to be negative 3 over 2 pi reciprocal, and multiply by that reciprocal each part of my inequality. Because when I do this, I'll be able to cancel this 2 pi and 2 pi. And looks like negative 3 will be over here and a 0 on the other side. And if I multiply by negative 3 over 2 pi, that reciprocal will actually cancel out with the original fraction. I have x in the middle of my inequality, with one little extra to watch out, and that'd be the sign flip, because that'd be greater, and that will also be greater than, because we multiply by negative. In other words, my curve now is going to be lying in between of negative 3 and a 0, but if you continue, it's still going to be going to 0.3 and 0.6 and 0.9 and various multiples of 3. That's one observation. There is one more. That 5/3 or so-called amplitude of this function will be actually the largest and the lowest values. No longer they are minus and plus 1, but 5/3 and minus 5/3. So whatever number is multiplied by, it's always going to be the amplitude. So it turns out same thing goes with cosines. So if I try exercise 17.
Yes.
So if I tried 17, then I would be doing pretty much the same thing. I just need to prepare now graph of function cosine of x. So that'd be my other one. So 1/2 times cosine of 3/2 x. So I'm gonna be also dealing with this cosine function, the new one that sits at the point 1 and then goes down and then returns back to the same level. But it's no longer at point 1. It's now going to be at point 1/2 because of that amplitude 1/2. So the lower will be negative 1/2. And again, I want to decide what about the argument. So that 3/2 x, the standard way, we put in between 0 and 2 pi, right? And then we're gonna need to take care of this 3/2. Its reciprocal is 2/3, right? So we're multiplying by 2/3 in the middle, 2/3 left, the right side. In fact, left side is always gonna disappear because it's 0. In the middle, it's always gonna be x because that's our goal, right? Because these fractions cancel. That's why we always do that. Now we have 4 pi over 3. Okay, whatever it is, I just put it here, 4 pi over 3. So once I was able to clearly describe the period of this function, you could just put a little bit more of it and you got the graph. So again, point of story that it doesn't really matter if you have sine or cosine, you follow the same exact process and you get pretty much same exact graphs. So in the next group of problems, there are more, and let me try one, like exercise number 51. Please notice that in that exercise 51, we have a little extra. They gave us here 4 added at the end. So technically, we're going to do exact same procedure, exact same graphing of a sine function. So we already know that's something like that. Reason, -6 is in front, right? So positive with a sign, we start going upwards. If it's a negative, then we start with going downwards. In other words, it's flipped. So to be able to graph a -6 multiplied by sine of pi over 3 times x, I'm going to have to now think about the period of this function, because I already know it's in between 6's, right? +6 and a -6, that sine function. And again, looks like I have a standard pattern. I'm going to put this pi over 3x in between, right? Just like we already did in a couple of exercises, in between of 0 and 2 pi, of course, and not 2 pi. And then ask ourselves what we need to pull out x. Well, that pi over 3 is not needed here, so I need to take its reciprocal 3 over pi. See how standard this is? Whatever we have with our x, we need to take its reciprocal. And it's always the case. And that's how I get x. And looks like the pi's will cancel. So I'm going to have number 6. And this is great because now I know what to put on the right side. But it's not over, right? Because now we need to have +4. Look at the exercise. They decided to add 4. Don't ask me why. They just put random numbers. That's just for practice, I guess. So when we have a +4 in the whole picture, we must move it up 4 units, right? and from here and from there 4 units. So what's gonna be our graph? Well, looks like the lower border, instead of being at the level of 6 was negative sign, now it's gonna be at -2. The upper border was at 6 plus 4 is 10. So I have to get a graph of that function. So somewhere in the middle here. So it goes down to 2, returns back to the level of 10, and then sinks down again. So this is what we have here. Again, we already know that this V was a number 6 on the right side. So put 6. And write down the equation, whatever it is, -6 sine of this pi x over 3. And after the whole thing is copied, I have to plus 4 to the whole thing. And of course, to make everyone happy, I can put a little bit extra on the sides, so like that. So although it looks a little tedious, but I hope you start to see the pattern. So all of these problems, they all have analogous procedure. With this add-in number, say 4, I wait, and I just graph whatever's without it, and then, well, decide to make a shift. Let's say, what if I now take a cosine for a change, like a number 49 that has -3 at the end? Well, I will postpone with that -3. In other words, I just graph -5 times cosine, and that'd be my first step. So the cosine of pi x, like that, without really caring what's in the parentheses, what the amplitude is. I actually just notice it's in between plus and -5. And since there is a negative in front, my cosine will start going from the bottom, increase up, and then return back. And this is the graph. The only thing, of course, I need is to get this favorite period in here, right? So pi x, as usual, in between of 0 and 2 pi. Well, you say, Alex, should I put the equal sign? It doesn't matter. We just care for pulling out letter x. That's what we really need. So whatever's on the right side will be the number that we are after. So x is in between of 0 and pi. Great. So I know what's on the right side. It is number pi. And now it's time to move, time to subtract 3. So I have to bring this picture 3 down, right? So we're gonna think of bringing this whole picture down by 3, so someplace to here, to the level of 2, right? So let's do this and we'll be done. So 2 is our higher one now, and the graph will go now somehow like that. And it will end at the point pi. And of course, here we're gonna have 8. Like that. So we shifted it down again because of problem that says subtract 3 from this whole thing. Let me write it. So you take that still 5 cosine of pi x. And you say, Alex, there is 5, there is no -5. Oh, no -5? Okay, so I can actually flip it, right? Because I wasn't careful. But as long as we noticed it, now it's fine. So it goes like that and like that. See, it's either flipped or not. And this one actually is without a minus. I don't know why I imagined the minus sign. but whatever, we fixed it, right? So -3 at the end means the graph fell down by 3 units. And I also gonna put a little extra on the sides like that. So that's our result, and I guess that's pretty much all this section is talking about. So I'd like to do a problem from the group of exercises above, very similar to the one that I can ask you for a quiz. I can do problem number 21 for you, and then ask you to do number 22 as a quiz exercise for today. So let us do one more time these ideas, and then you will try one on your own. So if I think of graph of 2 times function sine of pi over 2 times x, then what I will is look at function sine, first of all, which is here. So the graph is going to be starting at the origin, going up and then down, right? Now I also see the amplitude 2, so it'd be in between of plus and minus 2. So the last thing I care about now is pi over 2x. That has to be in between of 0 and 2 pi to start. And then we're gonna flip that pi over 2, write it as 2 over pi, and times it by each portion of our little inequality. So these are gone. 0 is on the left side, and on the right side, after pi was canceled, we got 4. So this is it. That's our little piece that I care about. So now I need to find one that starts at the origin, goes up, and deals with just number 4. And I think I can see it in the part F of the exercise. You see part F that actually has exact same structure. So from 0 up and then down, and then again up to 4. So the answer for this exercise is letter F. So all you have to do is just tell me the letter that corresponds to the graph of exercise number 22, since it is our quiz. So one of the letters, like A, B, C, whatever, definitely not F, because F is already taken, right? So which letter do you think has a graph of this equation, exercise 22?